today's tutorial?
In this course, actually, there is no kind of a tutorial because.
Okay.
But it's considered as a kind of tutorial, obviously.
So you are replacing Abid?
Yes, Asaf.
Asaf?
Yeah. Because he's not here, so I'm taking this. The syllabus is so large that if I start taking tutorial, it will be difficult for him to complete the entire syllabus. I'm not sure, should I start? What should I do? It's like two people.
This is the first time I'm coming.
Oh, you are coming for the first time? Okay.
Yeah, because I registered late.
Late? Okay,
yes.
fine. So
we can start because
it's recorded.
Yeah.
Okay. So okay, so hopefully I'm audible there. Okay. Yeah. So we'll start with the Maxwell's equation. So everybody here has taken electromagnetism course. Maxwell's equation you are aware of? Okay. So I'll write down the Maxwell's equation in the usual notation, that the way we write it, and then I'll try to use some tensor algebra and write it down into the covariant form so that I will not have to write all those four equations. Just by writing the two equations of all those four, and I will combine all four equations in the two equations. And the equation that you have usually seen, those equations are not, when I will write it down, you will see that these are not covariant equations. So the one which we will derive at the end will be covariant equations. How? Let's see. So let's write down the normal Maxwell's equation, which is unfortunately, I don't have habit of writing the vector notation. So if you find that I'm not writing vector notation, you should consider that it is vector. Oh, so I should not start it before. I have some things to say. So I am, and this is my office. This is my email. What else?
Akshay.
Yes. Thank you. You are the first one who pronounced it properly. Okay. So yes, and okay. So I'll not start right now. I have something to say about the homework. So I checked the first homework people have submitted. So if I remember correctly, the first question is to look at the transformation of velocities from one frame to another frame.
Yeah.
Something like that. I don't exactly remember the question. So what it says that some people have submitted the homework, not some people, almost everybody had submitted. So those people who have submitted the homeworks, you write down the transformation form of velocity like ux prime. Don't take this formula seriously because I don't know whether I'm writing it down or right or not. Something like that. It's not right, so I don't exactly remember this is the formula. So you directly start from here. How do I know that you know where does it come from? Some people have mentioned it that we used it from the like modern physics class, but here you just copy pasted it from somewhere else. In exam you don't remember this formula. You definitely won't remember this formula because there will be too many things to remember at that time. So if you write down this formula up here, it is going to be a problem for you itself, because at the exam, if you write down this directly this, you will lose half of your score. So you need to know how to derive this formula. Even though you already did it in the modern physics class, I know that. But if you are using this directly formula, this is not going to give you the full score. Okay? And when you write down any of the solution, try to explain yourself. Like you just write down this is ux prime, this is ui prime, and then I divide both of them, I got the answer. What is ux prime, what is ui prime? That's my job to check it out. So I'll not do that. But your goal is to tell me how is the transformation of velocity is done. Which frame are you looking about, which frame you are talking about. So you consider that I'm dumb, I don't understand anything, and you write down your solution. And I prefer if you write down the solution in LaTeX or any of the word editor. If you cannot write in any of the word editor, try to write in as nice handwriting as possible so that I can understand. And the last but not the least is that if you have any problem submitting homework, I think Asaf has already told in the very first class, you come to me beforehand that this is the problem, that's the reason I cannot submit the homework in the deadline. If you cannot submit the homework during the deadline, don't come to me afterwards. If you have any problem, come to me beforehand, or you are not putting any email to me. If you decide to put an email to me, I will not respond to that. So keep that in mind. If you have anything problem, come to me a day or two or beforehand and tell me that this is the reason I will not be able to submit the homework and I need an extension for the homework. Otherwise, you will have to go and explain yourself to Asaf, and then he will extend the deadline. I'm not going to do that. What else is there? Yes. So homework instruction is fine. Yes. And I'm here from like 7 in the morning till something like 6:30 in the evening. So if you have anything to ask, this is the place. You can come anytime, but don't like just barge in anytime. If you have anything to ask, put me an email, ask me if I'm available. So I'll be able to answer your question. Okay. I don't think I have to add anything more to it. Good. Oh, this is 2, by the way. Okay. What is it called? What is this equation called? What's the name of this equation?
I have a question about
This is one of the Maxwell's equation. What is the name of this?
the second term.
No,
Shouldn't
this
be
entire.
Faraday or something.
This is Ampere's law.
Ampere's, right.
What is the second one?
Gauss.
Yeah. This is Gauss law. What is the third one? You said earlier.
Yeah, Faraday.
Faraday's law. What is the fourth one?
I don't know if there is a specific name, but
Yes.
basically
What does it mean?
absence of
Magnetic
charges.
monopole.
Yeah.
Yes. So it doesn't have any name, but
Yeah.
this says that there is no magnetic monopole exist. Okay.
Shouldn't be in the first equation they derive it with respect to t, not to.
Oh, oops, sorry. Thank you. Yes. What did I do? No. This is 0. I'm not in good state of mind, looks like. Okay. Fine, so these are the 4 equations that we have. By the way, I will not take only 1 hour, I'll take the entire class, like usual 1.5 hour. Okay? So don't consider it as a tutorial. Okay. Fine. So what we are going to do now is that we have this usual equation, Maxwell's equation. We are going to write it down into a little bit different notation using the Levi-Civita. You are aware of Levi-Civita, right?
Yeah.
Okay. So I'll write it down, like write them down like, so let's okay, so what did I do in here? I introduced Levi-Civita, right? And if you are aware of Levi-Civita, is equals to +1 -1 0. Under what condition it is +1? When there is an even permutation. For even permutation, for odd permutation, for any other
repeating number.
yes, and it is I, J, J, K, K. Good. So this you are aware of. Now, what I did in here is I write this curl of B as epsilon I, J, K, D, J, B, K. So, so what I am going to prove to you now is that I did not cheat anything. This comes out to be equals to this one. So I'll just show you one of the terms. Remaining you will have to do it yourself if you are not convinced with why I wrote this way. So let's write down this one, epsilon I, J, K, D, J, B, K. Okay. And I'm trying to prove this is equals to del cross B. Okay. I or A. I, let's say I start for I equals to 1. Okay, so this is I. Fine. I start from any one of the term. So it would be epsilon 1 J K D J B K is equals to del cross B I. I is 1. Now when is epsilon I J K will not be equals to 0? When J or K will be equals to either 2, 3, okay, or 3, 2. These are the only two permutations that you will get the epsilon I J K which will not be equals to 0. I just put the value of, so when J and K equals to 1, then you will get 1, 2, 3. What is the value of 1, 2, 3 for Levi-Civita? Like +1. So it would be dz. Okay, so let's write it down this way and just write it opposite. 1 is equals to epsilon 1, 2, 3 d2 b3, okay, plus epsilon 1, 3, 2 d3 b2. And what is it equals to? Now let's consider 1 is x, 2 is y, and 3 is z. What will you get? This is the curl of del cross B along x direction. Okay, so this means this is equals to that. Good. So similarly, you can, if you want, you can prove this way, this one as well. Everything will come out to be same. So I did not cheat anything in here. I just wrote it down from that to this, and my handwriting looks really nice. I'm really happy with that. Okay. Okay, so in here, if you see there is a term J. You know what is J? You should be aware of J. What is J?
Current density.
It's called current density. You ever heard of this thing?
Yeah.
So you have what did I do here? If you remember, I'll just write down the continuity equation and try to derive the J. Remember this thing? This is continuity equation. I just multiplied by charge. So this is called as charge density. This is called as current density. So I just multiply in here, what we will get is like dou rho over dou t plus del dot.
J.
Okay, and here I define J as in the 4 vector notation. If I define J, J has a form of rho C times J. So this is 4 vector J, this is 3 vector J. So I think I should put this bar in here. Okay, so that's how the capital J is defined. These are this is the 4 form of the J. So I can also write this as a J mu if you want. So I can also write, if I want, like J mu will be equals to rho C J1 J2 J3. This is just for you to know what J is. Okay, this is called current density 4 vector. Okay, and this is invariant in the Lorentz transformation. That if you are not aware, you should be aware, and if you don't know how to prove that, come to me afterwards, I'll tell you. What I'm saying is that the current density 4 vector is invariant in the Lorentz transformation, because all these things which we are trying to do, why did at the first Maxwell's equation come into being? What was the problem with the Galilean relativity?
They were not invariant.
Yes. So if you look at the Galilean relativity, speed of light is not constant.
Yeah.
So if the two objects are moving, they can move with the speed of speed much larger than speed of light as well. So what we started everything in here is because Galilean relativity was not invariant. It was not invariant. So Michelson-Morley experiment, speed of light is constant. Then came the Maxwell's equation. So what we are trying to write in here is that these equations, I can write it down into the much simpler form using tensorial notation, which we can use later in the course. Okay, and that J is invariant, that you can also prove. Which
you mean it's known?
Yes, it's 0. So if I do this, it comes out to be 0. This is mu, by the way.
Like interval, the same. Interval is also
Why is interval in here? I don't understand.
interval from special relatives.
Yes.
It's also invariant.
So
right?
yes, it is invariant. So this is the time component. These are the 3 spatial component. So this is 0. This is 1, 2, 3. Component of the current density 4 vector. Okay, so fine. This was not needed. But what we are going to do now is to define the electromagnetic field strength tensor that you are supposed to know from electromagnetism course. So if you are not aware of this electromagnetism course, then you might learn this year from LE. If you are in 3rd year, I'm not sure. As Ellie is teaching the course on electromagnetism. So I define this tensor, which I call as electromagnetic field strength tensor. Have you seen this tensor before? Have you seen this before? Really? You did not take the electromagnetism? Oh, so it's in the second course in electromagnetism. So in the first course, it might not be there. Which book you, by the way, you studied the electromagnetism course? Go to book by David Griffith, Electromagnetism. There it is derived. Okay, and if you are more familiar, go to David Jackson, which I would not suggest you to go. But if you want, you can go to David Jackson as well. There also it is derived. So what I did is in here is, okay, so this can also be written in the very easy form as something like this. I hope you may have seen this equation as well. In the very simple form, I can write it down like this, where A is called as a vector potential.
4 vector.
Yeah, 4 vector potential. Potential, and it is written as A mu is equals to phi A. This is the scalar vector potential, and these are the 3 components of the vector potential. Okay. So for now, what I'm going to do is, I consider that you are aware of this term. I mean, this electromagnetic field strength tensor. If you are not, you consider that this is what is given to you, and I'm going to use this thing and write it down the equation. Write down the Maxwell's equation. Okay, so now using this electromagnetic field strength tensor, what I'm going to do is to write down the values of F0 I equals to EI, and then Fij is equals to epsilon ijk bk. Now okay, so these are the two. So we can actually observe that I can write down this component E using F naught I here. How? If you want to just simply prove it, I will not prove this one. I can prove for, you can prove for any one of them. How can I write Fij as epsilon ijk bk? I should not show this to you all, but okay. Because it is very easy for you to understand. So let's simply put F12. F12, whatever will come out is 1, 2, 3, B3. Let's say for k equals to 3. What is 1, 2, 3?
1 plus 1.
So what is F12? Zero 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 1 0 2 0 3 1 0 1 1 1 1 2. Okay, so good. So what I'm going to do is I am going to write down it like this, and now using these two equations I can write down the Maxwell's equation as, I hope it is visible. On the camera it would be visible, right? I hope so. So now the first two equations, I will write it down like this. So the first two Maxwell's, I write down equation like this, if you have not seen it. That is the short notation of equation for me. dj f0 fij minus t0 f0I is equals to 4 pi j I. So what did I do in here? I just write down these two things in here, these two equations, and those two equations using these two notations I can write down like that. You need to make yourself happy with it. If you are not happy with how can I write these things, that these two are equals to that, you just put the component wise. You have I, j and k, you just put the number as 1, 2, 3, whatever number comes out, and you will get the answer. Okay, fine. Now I can combine both of them into the single tensorial equation, which will say that d mu f mu is equals to 4 pi j nu combined into one. So now I combine both of them here into this equation. Now again, it is not going to be, people will not be happy, so I will try to prove that what I have written is not wrong. Okay, so again let's do the same job. So what we are going to do in here is, let's put nu equals to 0. Okay, so d nu f 0 mu is 4 pi j nu. Okay,
0.
Nu is 0, and what is nu? 0 is rho. Somewhere it was written here, I erased it earlier. If you remember, j has the 4, j4 has rho c times j. C we usually keep as a constant as 1. So this component is j0, I can simply write as a rho. Something started appearing from that side. Okay. Now let's write down for all the components of mu. So I have d0 f00, d1 f01 plus d2 f02 plus d03 f03, which is equals to 4 pi rho. Now calculate it, it will come out to be del dot E. F00 T0. So this is going to be 0 because F00 is 0. Okay, what is F01? E1. 1 is x. Let's put 1 as x. Okay, so this will be dEx over x, dEy over dy, dEz over dz. Okay, which is the gradient of E. So this is one of the equations. Similarly, you put in the other terms. Where is this equation? Here. You can prove that you can get the first equation as well. Okay. Good. So these are only the first two equations, first two Maxwell's equation. What I'm going to do, by the same reasoning, the way I prove all these things, and I put these two notations to write down these two equations. So I use these two notations to write these two equations like this, then I combine both of them into this equation. Similarly, I can use the same thing, not same thing, similar thing to write down these two equations using the similar formalism, and which I will not do, which you will do at home, and I will write down the next two equations, that means these two equations like this.
Can I just ask
Yes.
something first? first year, you already assumed that C is 1.
C is 1.
Yes, throughout the whole course.
Throughout the whole course, we are going to use C equals 1.
And one other question here, you wrote where you wrote the tensor. On the other side, you wrote it equals something else. I didn't understand.
Like
just
which
feel
one
like
you
you're
mean?
gonna erase it. Here, but you wrote the tensor with f mu nu equals this.
No, I mean, which one you were saying? This one?
Yeah, no, one above.
One over
Yeah,
here?
the right side. You
Yes.
wrote equals again minus.
Ah, okay. So, good. So, this I define f mu nu as a tensor. It is called as an electromagnetic field strength tensor, and it is an anti-symmetric tensor. Means if I change the symmetry of these two indices, I will have to put a negative sign there.
Oh, okay.
So here I have mu nu. I just reverse the indices to nu mu, and I put a negative sign in here.
I just thought it was a lowercase f and you normalize it.
Oh,
Okay.
no.
Okay.
That's a capital F. So because this is the anti-symmetric tensor, so I just put a negative sign, then I switch the indices. Okay, so the next two equations I can write the other two equations. I will write down like this: T mu F mu lambda equals to 0. These two, this is the third. Oops. These are the third and the fourth equation, fourth Maxwell's equation. How? Okay, I can prove for one here as well. So I have proof for this also. Where do I have it? Okay, so it's going to take a bit of space. What I'm saying makes sense, right? Okay. If you do not understand anything, please do tell me.
Why did
I
you
don't.
write brackets?
Oh yes, I will come back. I will come to that. Because I can do the permutation of indices there. I will write down at top. What do I have in here is so what does that bracket thing means is that we have anti-symmetrization of the indices. I can do the addition of all the terms that comes under this bracket. That is mu nu lambda mu lambda mu lambda mu nu. It's the addition of all those three terms. I will write it down, so don't worry. So I can write it down like, how should I write it down? Mu nu lambda. I have it here somewhere. Here. So it is f mu lambda plus f mu lambda mu plus f lambda mu. You would know that, right? This comma means derivative. And what does this mean? I think you have studied the covariant derivative. You have not. Okay, maybe then covariant derivative might come a bit later in the next class or something. Okay. So if I denote just by a comma, that means I'm taking the derivative of f nu lambda over mu. So it is f lambda mu. This is what I write it like this. This is just a simple notation. Okay. So what I'm going to prove by this is that this equation also means that, okay, the one I have is for the alpha beta gamma, and I will write it down in alpha beta gamma because when you do the calculation of this sort in this course, there is a very high probability that you might mess up in this index. So while you are switching the indices as well, be very, very careful how do you do the switches of indices. Otherwise, it might be very difficult. So I have written in the form of alpha beta gamma, which I will stick to that so that I will not make any mistake. This is the same as this, right? Instead of writing it like the comma lambda, I just take the derivative like this. This is the same thing. Whether I write this or I write this, both are same.
Why did you switch the indexes? Like the
I
names?
switched the indices because I switched the indices because the way which I have derived this equation means
Okay,
that
your
proof
notes
is in alpha, beta, gamma, and I don't want to like flip over the indices because I might make a mistake of +1, -1 somewhere. So I just don't want to change that thing. Okay. Can you close the door back? Again I do. For alpha equals to I, beta equals to J, and gamma equals to K. I changed it into FJK because I already defined this notation in FIJK, which I am going to use in here. Okay. So I have Fij is equals to epsilon this is fine. There I wrote with the upper indices, here I wrote with the down indices. Nothing I changed in here. Here you see Fij is up and I wrote with the upper indices, and there I am just writing it down with the down indices. So be careful while you write down this equation, because contraction of indices and writing down the indices, if you switch it from upper to lower indices, you will have to add a negative signs. Otherwise you are going to make mistake. So I'm going to write it down like this. Epsilon J K L B L I just wrote down the indices of this because Fij is epsilon Ijk Bk, because here this K is getting contracted and you are getting value of Fij, because the indices on both sides will be the same. Okay, so for that thing I wrote it down for everyone of those terms, and now you put down those values, you are going to get the equation as del dot b equals to 0. I'm not going to prove that. You put ijk equals to xyz. You just put the values of ijk which I have given in here as x, y and z component. You are going to get the answer. It will be dvx over dx plus dby over dy plus dvz over dz, which is going to give you the divergence of b equals to 0, which was the fourth equation by the way for you. So this ends the Maxwell's equation. So okay. Good. Now I have one or two properties of the Maxwell's, that F mu nu tensor. So if I take the product of F mu nu with itself, which I can write it down as, I write it down here, mu, it gives me the answer as 2 times b square minus e square. Since it is a tensor, any scalar from, since the F nu is a tensor, if I form any scalar out of it, it will be Lorentz invariant, because F mu nu itself is a Lorentz invariant. Okay. Similarly, I can determine the determinant of F, which will give me b square minus e square, which which also gives the same, which also says the same thing. So these are the two scalar product of, these are two of the properties of f naming, which is not very important, but if you remember it, it's going to be good. Okay, so now we are going to solve a few problems. Does anyone have any problem with this? Okay. So first thing I'm going to start with is contraction of indices. So I suppose Asaf has already shown you how to do the contraction of indices. So I have a question like I want to prove this thing. By the way, one more thing that is important in here is to note down how do you write the indices. I think Asaf has already told everybody. When these two indices should not be on one over top of each other. If you write like this is completely wrong. Either you write it like this, so there is a space just on top of it, or you write like this. There's a space below this. Okay, so keep this in mind that this thing you cannot write like this or anything like this. I mean, these are fine, but you cannot write like this because this is not correct. Okay, so can someone tell me how to prove this? Because it's just a very easy question. We'll have two lines of proof that you can show that these two are equal. You can use the properties of eta. If you remember eta? Now keep on filling those things.
Probably minus.
This is eta.
It's ones.
Yeah.
Minus 1, 1, 1, 1.
Minus. Okay. So now use the value of eta and try to prove that these two are equal. What I'm going to do now in here is like, okay, so let's write it down like this. Alpha neo. So I'll start from the left hand side. Does anyone have any problem with this?
It should be sigma.
So where should it be? Sigma, beta. Good. You just have to contract the indices and see that if you are getting the same indices on the left hand side and left right hand side. Okay, here we use the property that eta alpha beta is constant. Here we use eta alpha beta is constant. That means if I take the derivative of it, it's going to go to 0. Okay? Yes or no? This is fine?
Well, it's better by the first term, the derivative with respect to beta.
So here the first term is already with respect to beta. That's what we have to prove. Sorry, in here. New.
There is no. Right.
Yes. So that means this term is derivative with new. So what I did in here is instead of writing f alpha new, I take the contraction of indices, which will This nu are going to get contracted, I'm going to get the same answer.
That's
I started from f nu alpha. That's bad. Yes. I started with this.
okay.
Because now it will
Now
make,
it's-
yeah, now it is going to make sense. Yeah, I made a mistake here. Okay, yes, this is fine. So now I know that the beta derivative of eta mu nu is going to be constant, so I just remove that. That means the derivative will only be with f mu nu. So this is going to give me f mu nu beta f beta sigma eta gamma sigma gamma alpha eta sigma alpha, which I will write it down like f mu gamma f beta sigma gamma sigma is equals to f mu nu beta gamma. Just reverse this indices, I will get f mu beta minus f gamma beta. Is there any problem with that? What did I do in here is, like, I have the derivative of this thing. I know that the derivative of eta nu alpha with beta is 0. I have this thing. I have this already. I do the contraction of these two terms. I just take it out before any reason. So I have eta nu alpha. Oops. I wrote nu gamma. And nu and gamma are problematic. Just a second. Where did I write it from? Come on. Which one is it? Yes. So it should be. It is gamma. This is not nu. Oops. F mu eta gamma. This would be. There's new end everywhere. This is gamma. Right? It's going to remain the same. Doesn't matter.
yeah. You also works.
It's going to get contracted anyway, so. So, is this okay or not?
All of these tensors commute.
Yes.
That's why you can.
That's why I can write it down. That's why I can do all these manipulation. If not, otherwise I cannot do those
Yeah.
manipulations.
Mhm.
Fine. If you do not understand anything, please do tell me. It's going to get very confusing, because now here, I mean, I'm not sure. To me, it was very confusing when I learned it for the first time. So if you do not understand, do tell what you don't understand in here, because it's just the contraction of indices. You just need to know that the number of indices which are on the left hand side should be the same as the number of indices on the right hand side. And if one index is on the top, then the another index should be on the bottom. Then only the contraction will be there. Otherwise, there is no contraction. If there are two nus on the at the bottom, two same indices like 2 mu on the bottom on any side of the equation, that means your equations are wrong. If the two index are on the same side of equation, that means the equation is wrong. Or maybe you define the two index to be same, which you should never do, because it will be very confusing. Okay?
But if it's upper and lower.
If it is one is up, one is down, that's going to work. Yes. If both of them are in the down, then it's not going to work. then there is something problem with your either definition of indices or your equation itself is wrong. Okay.
Can we say that if some tensor is invariant,
Yes.
it will commute? With,
So I have a very simple problem for that delta in here. So what we are going, I will not prove that, but how much time do I have by the way? Oh, I have a lot of time. Okay. So the one question that I have is, where is it? Yes. Prove that Kronecker delta is a tensor. Can you do that? Just tell me how would you do that, because it's just single one line or two line answer. Can you prove that Kronecker delta is a tensor? I already gave you a property of a tensor. If you remember this, I said a statement.
Tensor acts on vectors and covectors, so we just need to show that after this action,
If I, okay, yes, go ahead.
we will get just
A scalar
constant.
We'll get a scalar quantity.
Yeah, constant.
Yes. What?
Yeah.
So if I have and which book, by the way, you are referring for this course? Don't say that you are referring to a subflexion. Please don't. Prove that delta mu nu is a tensor. That's Kronecker delta, right? Yes. The easiest way to show it is that del mu nu I combine with the two components of a vector, let's say a and a b, and it will gives me a scalar. If it does, it is. If it does not, it is not. That's the easiest way to prove, which I'm anyway not going to prove that, but if you can do it, good for you. I mean, you have to know how to do it, okay? Fine, so one thing that we are going to use in here is, I have to do something else, I forgot. Okay. I can erase it, right? Anyway, you don't need to write it down. Oh, you should write it down. I'm not going to provide notes. I mean, if you want to, anyway, it will be on YouTube. That is the not good part of this course, that everything goes on YouTube, so everybody can see what is going on. Which is really, really difficult and scary part. So I already erased the F mu nu, but if you remember, I defined the electromagnetic field strength tensor. So using that, I can also define the transformation of electromagnetic field. This you already know, right? Transformation of electromagnetic field. If I am given the electric and magnetic field in the one frame of reference, how will it change when I go to the another frame of reference? You do know that, right? Or no? Everyone here. If I am giving you the electric and magnetic field in one frame of reference, how does it transform into another frame of reference? Are you aware of it or not? By
other Lorentz
yes.
transformation.
It's a simple Lorentz transformation.
Yeah.
Like
Just act.
You just
interact
do
with
the
two
multiplied with
times.
lambda, you will get the.
Yeah.
Okay, so a few people are aware of it. So what I'm going to do is, like, I'll write it down very briefly. What I want to say is, like, f prime I j is equals to the alpha nu lambda beta nu F mu min. What am I doing here? It should be alpha beta. I have a f mu nu which is given into the one frame of reference, and I want to calculate the value of f prime that is in the another frame of reference. How do I do it? I just multiply it by the Lorentz transformation matrices. But there is a problem with that, because so how do you do the multiplication? You can multiply this first thing and then you can multiply this next. But when you will do that, you will realize that the indices that you are summing over will be wrong. So then you will have to take the transpose of one of the matrix. I will I will show you how you will go wrong. So f prime ij is equals to lambda I k lambda j l f k l. This is the same thing I just wrote. Instead of alpha beta, I write ij. Yeah, because I am happy with that ij and k. I don't want to make any mistake. So what I am going to do is, here I can just simply do this thing, right? How do I do this multiplication? I multiply lambda to f, and then once I get the result of that, I multiply it with another lambda. Good. So let's do step by step. So let's calculate first lambda f, which is going to give me unit, right? Okay, let's write down the summation. Lambda I k f k l. Good. This k is getting contracted. You have f, only one component is left. Now I have this result. I am going to multiply this with another lambda. So this is just this term I am calculating. Okay. Any problem?
Yeah. I mean, after you did first summation.
Yes. So this is just the first term, and now
Yeah.
I'm going to do another multiplication with another lambda.
Yeah, but you will have I and
Yes, I will do that.
upper indexes.
Yes,
right?
I will do that. So let's multiply another time, which is going to, now I'm going to calculate lambda times lambda f, which is going to give me the value as I k. Just check it out. How am I writing it down? Is this fine?
You're supposed to sum again, not only.
Exactly, I am supposed to sum over L, but if I do the direct multiplication, I am summing over I. That is what is missing here if I do the direct multiplication. That's why it's so like step by step. So if I do it first time, here I am multiplying over K. Now I need to sum over L, but instead I am summing over I, which is not correct. So what I am going to do in here is I am going to do the transpose of the second lambda and multiply it from the right hand side. Okay. Do you want me to show that? How is it done? It's fine. So what I'm going to do in here is, like, instead of multiplying it like this, I'm going to multiply it like this. I will simply switch over the indices from which are on the top and the bottom, and which is going to give me this value. This is going to give me the f prime. Okay. Now, okay. So this is understanding. This is the most important part, because after that is just multiplication. Now we know that for the, how is that lambda matrix is given? Gamma minus beta gamma minus beta gamma gamma. Okay, and if I write in the 4 by 4 matrix, everything else will be 0. So here it will be 1 1. Just keep on filling all the zeros down. Am I right? Yes. So this is my lambda. I already have the value of f, which I somehow erased. and then I have the value of lambda transpose. What will it be, by the way?
Same.
Same, exactly. So why should I write it down? Okay. Do you want me to write it down? Okay, I will write down the whole matrix multiplication. Now do the brute force multiplication of two matrices. This is your answer going to come. Beta times B3 gamma times E3 plus beta times B2 0 0 gamma times B3 minus beta times E2 minus F gamma B2. Be careful with my B and beta, because to me it seems like you will definitely be confused with that. So
B doesn't have any index.
okay,
It's not
yeah,
so much.
fine, okay, good. But you had to use another logic to understand that that's not beta. Good. Minus gamma E3 minus beta E2. I'm just writing down the multiplication of this lambda f I already defined with lambda transpose, okay?
Are you sure the 0, 1 component is 0? Isn't it supposed to be like antisymmetric?
My solution doesn't say like that. If it does, I need to check it down. I don't think so. Okay, let me write down, then we can check it out. Gamma 1, 2, 3, 4 E3 plus beta times B2 gamma B2 plus beta times B3 minus B1 0. Now compare this matrix with F mu matrix. What is this going to give you is how are those electric and magnetic field in one frame of reference is going to transform into another frame of reference. What I say makes sense. Now I have this where I am going to compare this with F mu nu. You remember that F mu nu which I already defined earlier. So this will give you E1 prime is same as E1, B1 prime is same as B1, and the other two components, that is E2 prime, E2 minus beta times B3 and B2 prime gamma times B2 plus beta times E3. E3 prime is gamma times E1 and B1, that is the x component of the velocity, electric and magnetic field remains the same, whereas these two components, if you have seen this, you should be able to recognize. If you have not seen it, so you should know that this is how it transforms in from one frame of reference to another frame of reference. Okay. These are the transformation field.
final tensor antisymmetric.
So
I mean, look
0,
at
1 should be minus E1.
yeah. Second row, first column.
If F is anti-symmetric after you do the
So my F mu nu is this. Let me write it down again. 0, E1, E2, oops, E2, E2, minus E1, minus E2, minus E3. I think earlier I defined the exactly opposite way.
No.
That was the confusion,
yeah,
right?
but still look at lambda F lambda transpose.
Yeah.
Yes.
In the first column, the second row.
Minus
Not
one.
here, not here.
Here.
Yeah.
You get-
First column, second row.
No, the
Okay. First
No,
column.
sorry.
that one
Yeah.
couldn't be there, 0.
Okay. So maybe I'm missing something somewhere.
Just minus E1 or something, right?
But I need to check it out. I'm not really sure. Okay, maybe.
We are just guessing that after we change reference, F should be anti-symmetric.
I need to verify that, so please. Okay, I'll check it out once the class ends.
Mhm.
Okay, so that is the only term which is problematic, right?
Right.
Maybe
Also
the-
minus in the one below it, because it's plus.
This one? Or you mean
No.
somewhere here? Here?
No.
Left.
This one?
Yeah.
So these two should be also minus?
Yes.
Yeah.
Because it has to be antisymmetric.
We'll verify that at the end. So, fine. Okay, you can already recognize that, that's good. Since I wrote it down with hand, there is a possibility that I can write it wrong. So, thanks for telling that. But I still will verify that, then only I will put any comment on that. Okay, good. So, is eraser. Since I'm not aware when will be my next class, so I'm going to take maximum of this one. So this is a very easy question, by the way, and the question is that consider a particle of mass m1 moving with velocity v and has corresponding relativistic factor gamma, hits another particle of mass m2 which is at the rest, and they get attached to it, which is also called as plastic collision, by the way, if you are aware of it. So we are asked to find out what is the ratio of masses such that after collision the new particle has a relativistic factor half. So the question is two particles m1 has velocity v or v1, particle has velocity v and relativistic factor gamma. M2 velocity 0 because it is at rest, okay? And what happens when they both collide with each other? They get stick to each other and the entire system starts moving. And we are asked to calculate the value of m1 over m2. What is the ratio of mass such that after collision, question mark, for particle has new for gamma prime equals to 1/2. Gamma half. So initially it has the relativistic factor gamma. They both stick to each other, and the entire system started moving. And for what mass ratio, the relativistic factor after the collision will be equals to this much. For this gamma factor, we are willing to calculate the value of those masses.
So
Very easy, momentum conservation.
After the collision, they are moving together.
Yes, like as a single system. Earlier, one was at rest, another was moving. They collide with each other, and the entire system started moving. Okay. So the momentum of particle 1 is E mu gamma times m1 comma gamma m1 b. For particle 2, blah 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 blah, particle 2. So I will write 1, 2, which is equals to m2 comma 0. This is what is given to us, right? This is the 4 component of the momentum. 4 momentum. Now after collision, can you see it? So what I consider is like after collision, the total mass becomes capital M, total velocity becomes V prime, and the gamma is also going to change. So that changed gamma I represent by gamma prime. Good. So now I'm going to use the energy conservation by energy conservation. So TION is simply written like this in my language, by the way, means that's how I write it. Does it make sense? This is the initial momentum, this is the final momentum.
So lowercase m, I guess.
Where?
In the second
Also
equation.
here.
Yes.
So this would be
M1, lowercase m1.
divide both of them, and I get V prime is gamma m1 V gamma m1 plus m2, which gives me gamma m1 plus m2 V prime is gamma m1 V. Some algebra will give me m1 over m2. I mean some algebra means you need to know how to do that algebra. I'm not going to do that algebraic stuff for you. Okay, do something, you will get this. There's nothing lot to do in here anyway. Now we express velocity in the form of Lorentz factor. How do we do that? You remember the gamma, how is gamma defined? Actually, gamma is defined as 1 over square root of 1 minus v square. I took gamma square. So, okay, this, then I will get the value of velocity from here. For a leading order calculation, I can take v as 1 minus gamma square, which will give me 1 minus 1 over 2 gamma square. Okay, just leading order calculation. I just remove the other parts. Okay, so now I have m1 over m2, which will be equal to 1 over gamma 1 minus, put this value somewhere. Where is this? I have v, put the values in here. Simply put the values and do the calculation. You get m1 over m2 is equals to 2 over third gamma. Now, algebra you are going to do. Just put this value from here and do. Okay? Good. So, when my ratio of masses will be equals to 2 over third gamma, then gamma prime will become equals to gamma. These are some of the very easy problems which I am taking because they are easy. In the exam or in the homeworks, they will definitely not be that easy. By the way, if you have any problem with the homeworks, please do ask me. Okay, so I still have 10 minutes. So this is very interesting problem.
The relation between v and v prime you get from gamma prime and gamma.
Yes. And okay, so now this question is very, very interesting, which I think you might have already seen it in modern physics course. The question is, prove that it is impossible for a free electron to either emit or absorb a photon. Prove that for a free electron, it is impossible to either emit a photon or to absorb a photon. Can you do that?
It's about Compton effect.
It's not about Compton effect, it is just about the conservation of momentum. So I will write it down like very briefly what I want to say by that. So the question is, so now we remove the trace of whether that thing was right or wrong. But please verify at home whether those negative signs were there or not, right? For the transformation of fields. Okay. Prove that it is impossible for a free electron to either emit or absorb a photon. How would you do that? Any idea?
You add the energy momentum and then you will get maybe V larger than C, like the velocity.
Okay, we are going to use what you said, but we are not going to get V greater than C. Let's check it out. So, using conservation of momentum, I can write it down PE equals to PE prime plus P gamma, where PE is the momentum of electron when photon is not there, when photon is there, and this is the momentum of photon itself. Okay? Okay, by the way, this equation here, when I'm writing P, these P, all P are 4 momentum, not the 3 momentum. Because otherwise, if you are writing 3 momentum, how would you write 3 momentum? You put a bar sign on top. That is going to be 3 momentum. Take the square of this quantity. P prime. Am I doing it right way or exactly opposite way? Okay. That's how I have defined in the answer, so I will stick to that. It is just the definition, okay? P prime when the electron is not there, when the photon is not there, when the photon is there, and this is the photon momentum itself. Fine?
It's like emission of photons.
Yes. So what I'm considering is like, let's say the electron does emit the photons, and then we'll come out to a contradiction that this cannot happen. This I will definitely not tell you what does it mean. What did I do in here? A plus B square.
Yeah.
Squaring. Okay.
Looks like the primes move the side to the.
No, actually, really? Oh, okay. Yes. So it should be like. Fine. Now it is good? Okay. Now you remember what is it?
Minus m squared.
Good.
No.
Yes.
Yeah.
It is
For-
minus m square
Yeah.
c square.
Yeah, but
I put
it's
C1.
Yeah.
So I have minus m square. Okay. So here I have now I think you will have some problem. What did I do here? What is the momentum of photon? This is an invariant quantity. What I am writing down in here is that this term. So even though P and P prime are going to be different, their inner product is going to be the same. And this is 0. Fine? Momentum of photon.
Yeah.
Everybody is happy with this thing. So what do I have from here? Okay, that's what it says. Now what it means that PE times P gamma, that is the inner product of PE P gamma, is 0. So what will happen when these two are equals to 0? When, under what condition this quantity will remain invariant? Now let's look at any reference frame where my electron is at rest. Okay. So what is the momentum of electron? So I write here. Consider a frame of reference. Consider a rest frame of reference. reference. What is the momentum of electron in that frame of reference? Does that thing make sense?
Yeah.
What I wrote? Okay. What is the momentum of electron? What about this thing? It's fine. This is this is going to be photon momentum in that frame of reference. Now do the dot product of both of them. Do you see any problem?
M is 0, but M can't be 0 and E can't be 0.
Exactly. Now if I take the dot product of both of them, that is m dot E plus this is going to 0. Okay,
Yeah.
because this time this is 0. But that means that m dot E is going to be 0. Can this happen? Can the photon have a 0 mass, 0 energy? Both are contradiction. So this proves that whatever I started with is wrong. It cannot emit. Here I just stated in one frame of reference. This is my chosen frame of reference, where I take the electron is at the rest frame of, electron is at the rest, and this has its momentum and energy, and you simply take the inner product, you get, there's a contradiction to the statement itself. It cannot emit. Otherwise that product is not going to be 0.
What will change when it's not free? That will allow it. When the electron is not free.
Okay, so so definition of free and not free is, so when I say free is that there is an electron which is just randomly for raised frame of reference which is in here. But when I talk about, so I will need to give example for something like solid state physics, or like you see lasers. What happens in lasers is like I give, means the electron jump from one energy level to another energy level. So I give some kick from like some methods. So electron jump from the lower energy level to higher energy levels. When they get back from the higher energy level to lower, then they emit the photons.
Yeah.
You have studied lasers, right? I don't know what else.
Under potential, this is the not free electron. When you have
Yeah, I
some
know.
kind of
I mean, how will we not get this?
So what will change in this solution, you mean?
Yeah, when it's not free, how will we not get this?
Yes, so
zeros?
there will be, so the thing is there will be an effect of potential, because here I'm not considering any kind of a potential is there in electron. I just consider that there is an electron which is just free. It has
The
nothing.
potential will be on the side where there is 0 and it will balance the...
Yes. Then you will do the energy and momentum conservation, it will not come out to 0. So, thank you very much for today. If you do have any problem from the homework, I can address that. If you don't, thank you again.
Thank you.
And please do tell me if you do not understand anything, if I speak fast, if I speak slow, if you don't understand my English. If there is any problem, do let me know. So, thank you. Oh wow, accurate. 11:32.
Here's the transformation.